here we'll be finding the derivative from the first principle. So when the questions in the exam ask you to find the derivative from first principles, this is what you need to do. This video is particularly for questions. I've had many students learn how to do the derivative, find the derivative with some rules, but they still forget to do the derivative from first principles. So what it is that we are looking at the basics, and the basic the definition of the gradient is to find the change in y divided by the change in x. Now, changing y is always in terms of calculus, and is found by applying the function to x values. So where you see here, instead of y we are writing f of something, f of x here, and when you this delta x, this is Greek letter delta, or letter, so it's just saying that there is a small change. Think of this as a small change, okay, a small shift to the left or to the right in x. A small change, or this is infinitesimally small, it's approaching zero, this change. Alright, so but we are magnifying this picture here for you so that this infinitesimally small value is actually has some sort of visible effect here, so we can clearly see this is the change in x. If we put the curve under magnifying glass and just look at it like that, these two values are essentially getting very close to each other in real life. Imagine that point, that dot there, that point there is here. We just magnified it for you to see better. So what is the change in y and change in x? Again, you might see these deltas when you write in the definition of a derivative from first principles. They just mean change in y divided by change in x. So we applying the function to this coordinate, and evaluating the function there, and we subtracting the original point from it. Okay, so the top of the fraction is changing y, like the y2 minus y1, and the denominator is x2 minus x1. This is one term, and notice this plus x and minus x cancel away. So where you see in your formula booklet this definition, you'll find this in your formula booklet, and when you see it, there was originally plus x here and a minus x here, which cancelled away. So that's why you don't see them anymore. So we are going to apply this to x squared. The question is asking us to find the derivative of x squared from first principles. So f of x is x squared. That's what we're going to do. Wherever we see this f function, we're going to replace that with the square sign. In this case, it'll be like so. The picture's coming up, and what it means is that go ahead, write x plus h inside the square bracket and subtract x squared from it. The denominator is simply just h. Alright, so I'm using, rather than a delta x, remember in our last slide we just had delta x, I'm just calling it h for simplicity, rather, because that writing that delta x is somewhat difficult for some people. So once you expand this bracket here, notice we are using binomial expansion here. So but if you don't remember that from chapter 8, binomial expansion, I suggest you have a look that up, and make sure you do that correctly here with the correct signs. There's a plus sign here, so everything should be positive. This minus x is part of the formula, and it's going to cancel that x square out. This is almost always a case that the first and last terms in this line should cancel each other out. So just remember that. And then that was the expansion of the bracket there. So now we can kind of h square from the top. This is again something that almost always, if you do it correctly, should naturally happen. This h cancels the denominator there, and by factorizing we meant factorizing h. I should have changed the slides there. So then now we got this definition where we got 2x plus h, and now we can kind of see that this h is approaching 0, so the final answer will be just 2x. Alright, so the 2x, as I said, on top of the page I've written everywhere you see delta x here, I had replaced it with a h in our working out, so that's what I mean. So finally 2x. So now do you remember what happened at the beginning of the lesson? I I was just guessing some gradients from x values there. So this is kind of a f dash function. What we just figured out is the f dash, or the gradient function, to be 2x. We had x values there, like -3, -2, -1, 0, and 1. So, and I was guessing the gradient with this. I was thinking this is the function itself was x squared, so the gradient function is 2x. So just double this: -6, -4, -2, 0, and 2. So every time, yeah. All right, so we look at another example next. Here we've got a constant in front of x squared. All right, so this constant, the trick is to think of it whether it's part of the function or not. Well, we squared the x and then we multiply. So notice there is no bracket here, so this is not the case where k is not inside the bracket. So k is outside the bracket. So when we applying what we have learned, the k goes outside the square bracket. Okay, so what you notice is that when you multiply it, expand the brackets here. I've expanded this bracket and I'm using delta x, and this k multiplies by every term there. So these three terms all have k's in them. The first and last term will cancel away as normal, and then you can factorize the delta x out of the numerator, and it should cancel away the denominator like so, and you're left with this expression here. Now, in this line, you can kind of put an arrow and say this is approaching 0. It's not 0, it's not exactly 0, but it's approaching 0, so we can ignore that, and the final answer is 2kx. Now, if you want to test it out for yourself, what it means is that, well, let's say k is equals to 4, so our y is 4x squared. So what it says is that now f dash is the gradient function is 2x. I'm looking below down there, and it's 2x times k, which is k is of 4. So this is actually in one of the examples 8x. So our gradient function will be that. So if we kind of came up, and we just saying that here we are evaluating that at x equals to 3, the y value is irrelevant for us. What's important is that x equals to 3, and we only need the x value to calculate the gradient there. So at point x equals to 3, the gradient will be 6. So now, yeah, here we've been asked point A is at coordinate 4, 16 on this curve here, y equals to x squared. Show that the limit of x is 8. So you, instead of x, we're just gonna use this number 4 in our working out. Remember, you have to do the same thing, but just when you're expanding a bracket, you will have some well, algebra should be easier with numbers. So you got a numerical example here, and this 16 and minus 16 will cancel away. So that's what happened there. These two cancelled away. Now on the numerator we can factorize the delta x there, and we kind of factorized it, and what we left with is there those means that now we can say this value is approaching 0 delta x, or final answer is that limit of delta x. We just need to come up with it. We went part A was just showing this up to this line, and then part B is to evaluate it. Means find the value of g, means the gradient is actually going to be 8. Part part B is to evaluate it. Take the limit. Okay. So I hope you have found this useful. Now I have some extra challenges for you. Have a go at question 3, and also I'm going to show you yet another question. This exercise is from 12b, alright? And this is the answer to part question 3. And then have a go also at this question here, part C, alright? Uh, Actually, we did this in question 12 in exercise in last slide. If you don't remember, just pause the video, have a go at it yourself. I'm not going to show you the answer again. And then this question is somewhat more challenging, but you should be able to do it. Okay, so because this function has two terms here, so it's somewhat challenging to know where this f delta x plus delta needs to go. So I'm going to show you there with that working out. So the first part, this everywhere you see x, you would replace it with x plus h, and this 4 also gets x plus h in the bracket there, but these two are just subtracted away, so they both have a minus sign there. Now I've expanded the bracket. The first bracket is these first three terms there, and that 4x plus 4h is like so. So you see that term at the front cancels with the x squared there. This 4x cancels away with minus 4x, but the h's remain, okay, in the numerator. So I've written the denominator like so at the end of the line. So you can factor h out, you get this purple expression here, and once you evaluate that, this h goes towards 0, and you're left with 2x plus 4. Notice the 4 does remain in the answer. Okay, so that's that. I hope you found this helpful, and I'll see you in the next video.